Okay, so here we're looking at the running analysis overview, and this is going to be the general. And in the general, what it does is it provides you some of that information, all on one page, and it's really an average of the overall performance. And what you'll see as we move into the next stage is going to be the detailed view, and the detailed view is going to give you a little bit more information, allow you to do some comparison between some points. So this is the view that we see in the online app. So through the web interface on your computer, and across the top here, we can see that this is in fact a run, and we've got two options, general and details, right? So it provides you the date and time stamp of the analysis, and we'll talk a little bit more about why that's an important feature in a little bit. Down below here, we can see their summary, and you can add in their painful conditions, whatever the case may be. You can add that also when you're taking the analysis, but it gives you another option to be able to take that right now. Total time of the run in minutes and seconds, and speed, cadence, and the type of analysis, which is a good feature just in case you're doing stuff either on a treadmill or outdoors, or because they are going to be a little bit different, even if you have someone run at the exact same speed, which could be interesting if that's something that you actually wanted to look at. So it provides you an overview of the output that we see right there. Going a little bit further down, you can see that there's this graphical representation of the cadence and the speed. And we're going to look at that in a little bit more detail in a second. But what it does is it aggregates some averages. So you can look at certain points. So let's say this was, a longer distance, and maybe it included some differences in speed or a hill climb or whatever the case may be. If you're analyzing, someone who was in competition and wanted to look at some of the differences between speeds, or like I said, the transition from an incline versus a decline versus a flat or something like that. So you can potentially notate that if you know the course and know the distance that someone was running. So you see that if you put your cursor over it, it just shows you the actual speed as well as the cadence. So it shows you the timestamp of when that occurred. So for example, if you know that someone was hitting a hill at approximately 16 minutes and 30 seconds, then you'll be able to see some of that transition, and the graphical representation will reflect that, and it allows you to look at a little bit more detail. Before we go to that though, what we're going to do is we're going to continue to scroll down. So this is looking at the averages throughout the entire run. So if you are looking at some real differences, in other words, you have someone running in some terrain that is not, consistent, then this may not be as important. But especially if you have someone running on a treadmill or running on a relatively consistent surface, then this will actually make a lot more sense, which is what a lot of times that we're doing when we're trying to identify a problem. But if it's for performance related, or you're having someone test out a course that they're going to be competing on, then it's kind of interesting. So we've got the asymmetry statistics. So we're showing that the symmetry between the right and the left foot in the contact phase. So when the foot is in contact with the ground, and we're seeing a slightly longer contact time on that right by 3%, that's within the normal. So it's going to be represented in green. And as you saw in the walking analysis, we sometimes use color representation to determine whether or not it's in the normal, it's approaching abnormal, or if it's abnormal in the red. So it's green for normal, yellow for abnormal, and then red, yellow for approaching abnormal, and then red for the abnormal. Now we don't see as much of that color differentiation here, because a lot of these metrics and markers are going to be speed dependent, and individualized. But in any event, let's move on, and we see the strike pattern. So we're looking at the angle of the strike, and this is representing and showing it's a rear foot strike, or a heel strike, as sometimes people will call that. This actually shows you the angle, and it's not the angle of the ankle, right? So it's actually the angle of the foot relative to the surface of the ground. Okay, so just make sure that you understand and notate that. But depending on the angle of the tibia, it could actually be very, very close. also gives you the contact force, right, in kilonewtons. So interesting, because that way we can actually see that. And then if you were to compare or have someone run a little bit faster, then you're going to be able to make some comparisons to the foot strike force as well as the position. So maybe they start running faster, maybe their strike pattern changes, maybe their strike force actually changes, and that can be represented here. The running profile, so typically as we see in the walking profile, it's looking at the stance and the swing phase. And unlike the double contact that we see in the walking, we actually see a double float here, right, which is the flight phase. And that's the biggest indication that someone is running versus walking. So we see the stance phase and the swing phase in representative of percentages, right, of the stride. And we can see the actual distance of each stride, 81 versus 83. So 81 on the left, 83 on the right. As we start to run faster, you will notice that these percentages will change. And again, that's why we're not going to be able to see, you know, a red, a yellow, or a green representation, or why we even bother breaking that down, because it's going to be highly dependent on, you know, how fast someone is running. A little bit further down, we can see the pronation and supination angles. So this is on strike, so the landing, and we're going to look at it advanced here in a moment, but a negative angle reflects a heel that is going to be striking with an inverted position, sometimes referred to as sort of that supination. And then the transition is once the foot goes from strike and the toes actually come down in contact with the ground. So that's referred to as the transition phase. In walking, we call that the foot flat phase. And then the propulsion, as we're moving into late stance phase into early swing phase, we get that as well. So we can click on advanced right here, and it gives a little bit more detail and look at that particular trajectory. So normally, as we go into the toe off position, we often see that trajectory look like it's going into a little bit more pronation. But keep in mind that if you followed, you know, the pattern here that we talked about in the walking, that we're looking at the foot as sort of a basic whole model, right? So we're not actually looking at the forefoot, which is typically described as that multiplanar or triplanar action known as supination and pronation. So we're just looking at that trajectory of the midfoot. Now, typically the heel, when you on a strike pattern, it's either slightly inverted or closer to neutral, and then we go into that foot flat position. That trajectory should go closer to a zero position, from negative to zero. And then oftentimes, and I know for a fact this particular person does continue that trajectory into the propulsion in a slightly lateral aspect. So they're not really transitioning very well onto that first and second ray. And that's represented here in the angulation, versus, as we can see this one, that this is a much more neutral or normal pattern, I should say, during a walking phase. The other thing to take into consideration is these dots, as we put the cursor over it, it actually gives you the numerical value, and it also shows you the min and max, which is, it's actually the standard deviation, which are these thin lines on either side, right? So we see that there's not only a difference in the trajectory, but we see that the standard deviation is greater on this left foot than it is on the right foot. So the right foot, we're actually seeing a fairly normal representation of about, you know, a little bit more than 2, almost 3%. And it's much greater on this side here. And it's kind of approaching, you know, sort of an abnormality. So we find that somewhere between 2 and 6% of variability is considered to be fairly normal. Less than that actually is not normal. So they've kind of lost their ability to conform to a changing environment. So if we want to, we can also click on relative. So what relative does is it uses the transition phase as sort of a zero mark. Okay. And then we can look at what if we were assuming that that was a zero position in the contact phase of basically foot flat position, what the deviation looks like on heel strike and into that toe off position. The other thing that we see here is the relative percentages in the landing, and then transitioning into that propulsion phase before the foot comes off the ground. Okay, we're going to go back up here, and we'll see that you can actually, press on the cursor, and again, it's going to show you some of that information, and you can be a little bit more detailed if you wanted to do sort of a comparison between the two. In the next phase of the overview, you're actually going to see a little bit different, where you can take two of those points and get some very, very specific details that provide you a little bit more information.